Okay, hello, welcome to another video of data science with Julia. So what we are going to be doing in this video, in last video we just saw like how to determine which column that needs to be split first in for a decision tree, right? So, and we are going to code a function to what to say, find which column that needs to be split first and all those stuff. And finally, we are going to finish it off writing the decision tree itself. Hopefully, I don't think it's a long video, but yeah, like I'll just try to keep it as short as possible. But I don't want to make it a video where people can't understand. Okay, so that's the thing. If it's long, yeah, please excuse me, right? So, like the first thing we need to do is we need to split columns. We need to take the average entropy of split, and whichever is giving the least average entropy, that column should be split first. So you have a function like, okay, come to the cell 4 over here first. So you have this average entropy after split. So over here we are giving a data frame called df min columns. This is nothing but like in the previous video, the data frame where only I just select the sex, passenger class and survive. Okay, so that's the thing. And for this we need to give like which is the dependent feature. Actually survived is dependent on sex and passenger class. So that's what we are assuming. Okay, due to the due to our understanding and due to feature engineering and all those stuff, right? But yeah, this is learning stuff, so things are easy over here. But in reality, yeah, like it could be very tough or something. You could be answering a lot of questions and all those stuff, right? And we just want to split by p class and see what is the average entropy, and gives like 915 and all those stuff, right? So passenger class. Okay, so that's the thing, right? So let's see how it works. Okay, so you have passed the data frame over here. So that is df min calls. Okay, so that you have just passed. Dependent features survived and p class is feature to split. So first what we are doing is like we are taking feature values. So in p class, what are all the values? Okay, that we are just taking in this line. So it should be 1, 2, 3. Okay, so total entropy first I'm just putting it like 0, right? Now for each and every value in this feature values, okay, what I'm just going to do is I'm just going to write a filter. So if the value is 1, okay, it's going to put a filter where the value that is the p class value should be 1. Okay, so and then it's going to split it. Okay, it's going to split based on this filter. So all the data that has a p class value 1 gets split over here, and over here total entropy I'm just adding, that is 0 plus an entropy of this split. Okay, so where p class is 1, that has been what to say, in that we are taking the dependent feature, that is the survive. Okay, so over here in this split we just have only the data set where what to say, p class is 1. Okay, and in that we are just only taking the survive, that is the dependent feature, and we are calculating the entropy and adding it to total entropy. Similarly, for all values like class 1, 2, and 3, this will happen and total entropy value will keep increasing. Okay. Finally, we are just putting out the average entropy. So, like, okay, here we are just doing set off. So, even if you have got like 100 ones, 52s, 200 threes, or something like that, it will just be 1, 2, 3. So, the length will be just 3. Okay, I don't know about the efficiency and all those stuff. My first idea is to get somehow this decision tree working, because okay, let me tell practical scenario. When I do a lot of data science stuff for my clients, like mostly decision tree seems to be the most successful. And I also read in other literature like kind of more than 50% is supposed to be decision tree. Like that seems to be one of the most successful algorithm. And I just want to know how it really worked. Like not just, I just don't want to use the scikit-learn and just finish it off. So yeah, like so I just want to learn. I'm just doing this, and it's not about efficiency. So I don't know how efficient the code is, but yeah, just forgive me if it's inefficient or something like that. So I'm just putting out the average entropy, and we are just getting it like 915. Okay, similarly for if you do it for sex, like it'll split by male, female, and it'll just do the total entropy and calculate average. It's becoming 0.76. So which is less, p class is less or 6 is less? So definitely 6 is less. So the first split is going to be using the column 6 or gender. right? So that's the thing, right? So next, what we are just doing is, so that's what we are just doing. So like we need to compare these two and select 6 is the column that needs to be split. Okay, so that's what we are doing out here. Column to split. That's what we're just doing. Data frame and dependent feature we are just having. And okay, this I think I need to remove. So okay. So over here we are having this features. Okay, so I hope still this still runs okay. Okay. Yeah. So we are having features. This is nothing but in this data frame. We are just taking okay, like okay, we are just taking sorry the names, that is like all the column names, and we're just taking out the dependent feature. That is, we are just deleting the dependent feature. Okay, because why do we need different dependent feature? Why do we need to split on based upon like survive? That's the thing we need to determine, right? So if you split it based on the dependent column, it makes no sense. Okay, so we are taking all the names, or that is like column names in the data frame, and we are just removing the what to say survived out. Okay, so yeah, if I do this column to split, it'll just say which column to split. Okay, and first we are just putting feature to split is equal to nothing. Okay, so nothing is a very special value. It just mean like just think it like, okay, it's not even zero, it's not even a number, it's a very special value in Julian. Okay, so it means that it's nothing. Okay, I don't know how to explain properly, but yeah, so that's the thing. Okay, so if nothing to split, it'll just return nothing. Okay, right? Next, I'm just taking the least entropy. This I'm just putting it like the entropy of the data frame itself. Now I'm just putting like, okay, the data frame entropy itself as the least entropy. Okay, now for feature in features, like okay, like for okay features, you'll be having like over here what you'll be having is like, okay, the names are what, like sex, p class, and survivor. Survivor would have been removed. The features will be sex and p class. Okay, so for each and every feature, okay, what it's doing is this is taking the split entropy. Okay, that is like average entropy after split. It's just taking, okay, and if the split entropy is less than the least entropy, that is the past that is in this case the first time it is the data frames entropy, then it makes the least entropy split entropy. So what happens is, okay, so first time it just comes like, okay, like okay, so I think the data frame entropy is 0.95 or something like that, right? So 0.96, okay, right? So now what happens is, okay, so this one, the P class, okay, the 6 entropy is 0.76. So of course, so this becomes true because 0.76 is less than 0.96 and all those stuff. So now the least entropy becomes 0.76 and whatever, right? And the feature to split becomes 6, right? So that's the thing, right? So that's how it just happens. And next time it takes P class. Okay, so let's assume that the second thing it just takes P class. Okay, so now what happens is the split entropy becomes like 0.915. Now actually the least entropy is actually 0.76. Okay, so this loop won't even get executed. So now you just return the features, features to split. Now it is actually 6. Okay, so that's how it is. So if you don't understand what I'm saying is like it's better to put it's better to take a paper, put all these values, okay, like features to split, least entropy, and feature and all those things, okay, split entropy and all those things, and then for each and every iteration put the values what they will be, and finally you'll just understand. Like we used to do it while we are programming in 5th grade or something in computers, but yeah, now I just don't do it, but I could understand it just like that. But it is a very good way to understand. We just put like, oh, okay, column names as features to split, least entropy, and all those stuff. For each and every iteration, we will write the values, what it will be, and this condition will also be a column. So if this becomes true, yeah, and then what that will be, and all those things. So okay, that is okay. Like I don't want to explain it in real detail, but maybe I might put a video about it, like how to debug a programs or something like that, right? So that's the thing. Okay, yeah. So, but yeah, I hope you understood it. So this will return 6. Okay, so that's the thing. Okay, so and what we are doing is next is we are doing a function called split by. Okay, so what this will do is like, okay, if I just give this df of min calls and six and all those stuff, what it'll do is it'll take this data frames, that is df of min calls, it'll come out here and the feature will be six. Okay, so it'll take the feature value, so it'll be male and female. Okay, and it will take another thing called splits, that will be a dictionary, now an empty dictionary. So for value and feature value, so for each and every value in male, what it'll do is like it'll just apply a filter. It will create a filter for only male and it will take the data frame only for male. So where the sixth column is male. Okay, and it will just put like split of male is equal to this data frame. Okay, so that's how it is. And similarly, split of the next iteration will be female. The split of female will be a data frame containing only female values. So that's what it will do. So this is a thing that will really split for us. So we know what to split. Okay, and now what we are doing is like we are really splitting it. Okay, so that's the thing. Okay, and of course don't if some people are efficient freaks, they might be jumping now, but yeah, it's not about like efficiency now, so it is more about understanding this stuff. Okay, right? Okay, so similarly if I just put like df of male survive column to split, nothing will come out. That's because like in df of male, like the survived values is okay. If we even once again split by what to say, no matter whatever column we split by, okay, its entropy will increase. That is, the average value will increase. So it'll just be nothing. So nothing will be returned over here. So, so like yeah, we know there is nothing to split. So by having these knowledges, we can build finally a decision tree. Okay, so over here, yeah, I've just put like okay, column to split df of male survive not equal to nothing means can be split or it cannot be split. Okay, so it just says it cannot be split. I don't know why this column to split keeps coming up, but it keeps coming up. Maybe like since I'm returning out nothing, a function should return something, right? So I think so. It's just returning the function itself or something like that. So that's what I just feel, right? So but yeah, I'm not sure. I'm not sure. Okay. Okay. Now let's go into this decision tree. I hope you understand. Okay. First, okay. What happens is okay. In this case, we'll just see like df of male. Okay, there is nothing to split. Okay, so we just put pass in data frame and we just pass survive. Okay, so column to split we just ask and there is nothing to split. Okay, so if there is nothing to split, what happens is it takes the highest vote. Okay, so I will explain to you with this one, right? So first, okay, just imagine this one. Just imagine these blocks. Okay, right? Okay, I'm just concentrating only on this one. So let us do the least thing and then go to complexity. Okay, so that you can understand. So the okay, so what is the feature survived? Okay, so what it will do is it will just take the survived. Okay, so it's taking the survived over here. That is a dependent feature we'll pass. Okay, so we are just passing it over here, right? It will just take it. Okay, so and it will take the counter and it will do the highest vote. Okay, and it will just return. So over here actually for men it's actually zero, like most men didn't survive Titanic, right? It's women and children first, and you'll discover what women and what women, okay, like which women survived. Okay, so that's the thing, the most, right? Okay, so let's see. Okay, so highest vote and so it will be zero over here for men. So the split is nothing as you saw over here, right? So it will return zero. So what it will return is three of actually what it will return. Okay, so actually it will what to say, like it will return zero and that's it. Okay, so yeah, now let's come to this thing like decision tree of df of mins df of min calls. Okay, right? So you just pass this df of min calls. Okay, so the first column to split is six. Okay, right? So that's how it is. Okay, so what happens is the first thing is split column will be what to say, six, because like for this one df of min calls, the split column will be six first. So because I think we saw it somewhere. Yes, df of min for survive it will be split. Sorry, it will be six. Okay, so it will be the sixth column that should needs to be split. So this equation goes to false. So what it will happen is it'll just come here. So now it'll just put like, okay, tree of split column, that is 6. So you're having it over here. So 6, okay. So you're having it over here. For key val, okay, in split by data. So split by what it will return is, it will return something like this one: male, female, data frame of male, data frame of female. So the male will be in key and the data frame for male will be in this value, okay. So now we are just putting a filter condition. We need to split only males because the first key will be male, right? Okay. And then filtered data frame. Okay, the filtered data frame will be data frame of filter. So this filter condition means it's only males. So we'll only get the males data frame. And what we'll do is like tree or split column of key. Okay. So you know what split column? Okay, split column is what to say? This one 6 and the key is male, right? And decision tree of filter df dependent feature. So decision tree of filter tree. So now it will be like decision tree of df of males. Okay, so it should be like okay, like decision tree of, yeah, it should be like this: decision tree of df of male and survive. So this will return 0 because it will come out here. There is nothing to split and the highest count is 0. So that will get populated over here. Okay. Now once again, okay, so it will just come like this. Okay, so first it will just come over here, split by 6 min. Okay, so nothing to split, so take the survive and just return the highest thing. That is like, what is the max? What is the max of survive? Okay, take survive. What is the max of survive? So it will return 0. Now it comes to women. Okay, so okay, if you want, you can work for women. Okay, so okay, yeah, this one. Okay, split by 6. Okay, df of female is there, and I'm just doing column to split, and it will still go to p class. Okay, so for the second time, what it will happen is for women, it will come over here, and this will become p class. Okay, right? And what will happen over here is, over here, like it will become like 1, 2, and 3, and the data frame. Okay, like let me explain over here. So women for it, we are trying to split for women, and it will say that okay, we can split by p class, and for p class has the values 1, 2, and 3. So it will iterate for 1. It'll check for 1. So once again, this data frame of women that belongs to only class 1. Okay, that is p class 1, will be checked whether it can be split. If it cannot be split, it will look at the max and return the max out. So the max of survive. So that will be 1. Similarly, it will happen for 2, and similarly, it will happen for 3. For 3, the maximum of survive is 0. Most women in third class did not survive. Okay, so that's how it is. So that's how this algorithm kind of works. So I just encourage you to take a pen, paper, and then try it and see it out and all those things. I hope my explanation is okay. So that's how it is. So it'll just try to split. If it's a data frame that can be split, it'll come over here. If it cannot be split, then it will take the dependent feature that is survived over here, and it will return the highest over here, and that will form the leaf node. So this is how it will build in data tree. So all these kind of reddish or pinkish thing, okay, these are data frames that cannot be split. Okay, and these are bluish things are data frames that can be split, and these things in decision tree are called as leaf nodes. That is the end thing, right? In tree also, if you just go branch, smaller branch, and finally it'll become leaf. Sometimes, of course, you'll also find fruit, flowers, and all those stuff, but yeah, mostly leaf, right? So we call it as leaf things. Okay? But the thing is, like, here you can just find a disturbing figure. Like, even the women of the third class, they didn't survive. Okay, so like so that's the thing. And but the women of first class and second class did survive. Okay, and the men didn't survive. So even though in the cinema and whatever, in books or whatever it is, if you read like women and children first, the captain saying as women and children first, and you expected women of all classes to survive. No, it's not. Okay, so, and maybe like, yeah, in the movie I saw like where the third class or something, like chambers were sealed or whatever it is, so that like they were left to die. Possibly that could have happened. And I don't know. I really don't know. And but yeah, a very very disturbing thing. And but yeah, that's how the world had worked, and that's how, and we have inherited such kind of world. Okay, so yeah, and that's how it is. So men didn't survive no matter what. In women, okay, the second class and the first class survived, the third class didn't survive, right? Very understandable, right? So maybe we can write a program that will take this dictionary, and if you just give values for, okay, like what to say, like whether a person is gender is male, and if the person class is like 1, 2, or 3, then it should give an output. So once decision tree has been learned, it's very efficient. Look, it's just a dictionary. So it's just looking dictionary values, and that's very fast, and it'll give a result out very soon. And if you're wondering, usually decision tree are used only for categories. Like we don't use it for regression. For regression, you can look like, okay, what if I want to use it for age? Possibly you can split the age like this. Okay, age greater than or equal to 18. You can put a new column like what to say, what to say, children or adults. Okay, so like for children, yeah, like that will be what to say, like what so for the children, the value will be children. For the adults, the value will be adults, and that column can also be passed over here. So children or adults, that column can also be taken over here. But yeah, the purpose of this video is like is to explain it as simple as possible, and to write our own decision tree stuff, and that's the thing. And I think I'll also add this to this ML, this decision tree, so that possibly in the future we can use for something. So that's the thing. But decision tree is usually used for what to say, categorical values. It's not used for continuous values. And if it's continuous, you need to break it into blocks. Like over here, children, adults, or something like age from 0 to 20. Sorry, 1 to 20, 21 to 40, or something like that. That can be done like and that, or something like that. So young, old, or something like that. So yeah, so you can split that into categories, and you can use that in decision tree. Okay, but yeah, the result is very very efficient, and it's human understandable. Like you can, if you can write a program to plot this as a tree, you can understand it very easily. Okay, reading as a dictionary might be confusing for you, and if you can write a program to read this dictionary and just give the output very fast, it will just give the output. So training might take time, but what to say, this thing will happen very 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 fast. Like or what to say, like after training, you need to implement this thing, right? So the prediction will become very fast. So that's how it is. Anyway, thanks for watching this video. I hope you understood about decision trees and at least feel comfortable about it. Yeah, do try these programs and try to see how it's working and all those stuff. And yeah, anyway, thanks for watching. Hope you have a good day.